Okay, so in this video, I'm going to give an example of how this parameterization works. So basically, the whole time I've been talking about this, I've been talking about taking a value t, which is the ratio of sides of sine and sine to cosine, sine theta to cosine theta plus 1. So if we can imagine having points on this circle down here, then I know that ratio is going to get smaller and smaller and smaller. So I can take that ratio for any small numbers all the way down to 0, and I can plug it in to our formulas here, and it'll give me the coordinates to a point on this circle. So that's why this is important. We're finding that we can take any rational number that we know and plug it in and get, and this works for irrational numbers too, actually. But more on that later. This is going to be a parameter that gives us points along the circle. So let's just look at that right now. Let's imagine t is 1 over 10. I know that's going to give me some point kind of around here. I don't know the exact coordinates of it, but I know that the sine of that theta, the vertical distance between that and the axis, it looks to me like it's 1/10 of the 1 plus the cosine of that point. Cosine of the corresponding angle for that point. That's what I'm trying to say. Okay, so let's take t is equal to 1/10 and see if we can get these coordinates from that. So I know the cosine of theta is going to be 1 minus 1/10 squared, or 1 over 100. And then I know it's also going to be 1 plus 1 over 100. Basically gives me 99 over 100 divided by 101 over 100, which just gives me 99 over 101. Okay, and sine theta. Well, sine theta is going to be 2 times t, so it's going to be 2/10 divided by 101 over 100. 1 plus t squared. And that's going to be 2/10 times 100 divided by 101. And so this is going to end up being 20 over 101. Okay, so now look up here, we have cosine squared. So to verify that these are giving me coordinate points on the circle, I'm just going to plug them in real quick just to verify. So it's 99 over 101 squared plus 20 over 101 squared should be equal to 1. So in other words, all I need to do is verify that 99 squared plus 20 squared is equal to 101 squared. Because I would square the denominators and then multiply 1 times the square of the denominator, which would just give me 101 squared. And this is true. That is a Pythagorean triple, 20, 99, 101. And so this gives me the coordinate points on a circle. So 99 divided by 101 and 20 divided by 101. Okay, so now that we know that t is a parameter, we can do any number we want t and will give us a parameter. If we get really, really small rational numbers, we'll know that it'll give me a point over here. If I do, say, let's say I take t to be, let's see. Let's say I take t to be this number here. What t value would give me that coordinate point? Well, that would be sine of theta there would be 1, and cosine of theta for that point would be 0. So 1 divided by 1, so that t is equal to 1 should give me that point. So if I take t to be 1, let me just draw a line, then cosine theta is equal to 1 minus 1 divided by 1 plus 1, in other words 0, and sine theta is equal to 2 times 1 divided by 1 plus 1, or 2 divided by 2, or 1. And that's exactly what the cosine and sine for that point, for those points are. Because cosine is 0 and sine is 1. Okay, so besides that, we can take, so from 0 to 1 gives me all of the points in that quadrant. So what about this quadrant here? Well, that, if I want to find a point in that quadrant, well, I tried t is equal to 1/10. Let's try t is equal to 10. So I have cosine theta is 1 minus 10 squared divided by 1 plus 10 squared. So that's going to be negative 99 over 101. Okay, so that looks really similar to the one I had before. The one before was 99 over 101. And then sine theta is going to be 2 times t, so 20, divided by 1 plus t squared, so 101. So negative 99 over 101, and we could just plug that in as well. Negative 99 over 101 squared plus 20 over 101 squared. I mean, we can verify that it's a point on the unit circle by checking that. And this is exactly the same as before. We just have the negative value here. So t equals 10 gives me the reflection over on this side. It gives me that point over here. And so we can keep doing this so we can see that for any t value that we plug in, we're going to get from 0 to as high as we want. But it's going to be, we can never get pi values with this. So if the point is here that we're trying to check, actually I think I did another video and I forgot to mention that pi was one of the zeros that we couldn't uncover using the parameterization, because we'll get more into that later. I'll probably redo that video later, but we don't have a t value that gives us that answer here, that gives us negative 1, 0 as coordinate points. But any of the other points we can get using this parameter method. So I could go on and I could show you how to get more Pythagorean triples. The Pythagorean triple here was again 99. 99 squared plus 20 squared is equal to 101 squared. That was the same as before. So we see that t equals 10 and t equals 1 divided by 10 give us the exact same Pythagorean triple, just different sections of the circle. All right.